Okay, let's talk about domain and range. Now, when we are talking about the domain, we are talking about the set of all possible input values that we usually put, which are x values that the function is allowed to accept. We have a range. The range is the set of all output values that when we usually input, the function actually produces after taking in those domain values. So now imagine, let us say you have a vending machine. So on a vending machine, let us say uh you have maybe Doritos. You see Doritos here. Let me say Doritos consists is maybe it prices about 3 rands. So the price of a Doritos is 3 rands. Let me say it's 3 rands. So when you insert 3 rands and you press the code and the coordinates where the Doritos are located, and you will get Doritos. You press the code and you insert 3 rands, you will get Doritos. And let me say you have a lunch bar on your thing there. Let me say you have a lunch bar. So when you have a lunch bar, let us say lunch bar is worth 5 rands. So when you have 5 rands, you insert 5 rands, you get a lunch bar. You get a lunch bar when you insert 5 rands. So now let us say we are talking about the domain on our vending machine. So you know that when you are looking for a lunch bar, you must insert a 5 rands coin. You cannot insert 10 rands and you expect the machine to give you a change of 5 rands. You cannot insert 10 rands and you expect the machine to give you 5 rands. Usually inhibited that thing. 10 rands is something like a paper and 5 rands something like a coin, so it won't align with the machine. So that is the amount that is not allowed, that is not possible to put inside the vending machine so that you can get your output. I hope you understand. So you cannot insert 10 rands and you expect the machine to give you a lunch bar and a change of 5 rands. This machine is strictly that you must insert 5 rands, a coin, so that you get a lunch bar. So this is how it is. So now, again, let us say we are talking about the range. So let me say when you are talking about the range, we are talking about like a price of a something greater than a lunch bar. Let me say you want a cold drink, and you know that on our machine we don't have a cold drink, and you know that maybe a cold drink, a maybe let me say less than a liter, yeah, less than a liter cold drink, 0.5 liters of a cold drink, it's worth about let me say it's worth about 5 rands. It's worth about 5 rands. And you know that on our machine, we don't have the cold drink. We don't have a 5 rand cold drink. So this is what is inhibited. You cannot insert 5 rands and you expect the machine to give you a cold drink. But a 5 rands is allowed. But you cannot insert 5 rand and you will get a 0.5 cold drink because the machine is inhibited that you get the specific snacks or maybe the chocolates that you want to get. So that is what function on domain and range is based on. So earlier on we give you a graph of 3x plus 4 that you must use this graph as an example. So earlier on I gave you a graph like this. So if you watch the video before this one, you will see what I'm talking about. So the video was about this graph. So I gave the example about this graph that we're doing example about this graph of 3x plus 4. So now let us say the question says determine the domain and the range of a graph. So now you have to simply now go back to the definitions and now ask yourself, what is the domain and what is the range? So we said that the domain, it is the all output, it is all possible input values. It is all possible input values. That is the domain. So the range, it is all possible output values. So now what are all possible input values here? So now when I insert every value from starting from negative infinity here up to positive infinity, I will still get my output value. So it means on my graph of 3x plus 4, if I insert every value, it doesn't matter it's negative 99, it doesn't matter it's negative 1 million, I will still get my output value. I'll still get the answer. It means I will still get the answer if I input any value here. I will still get my output value. I will still get my output value. So what do we call this? So the reason why we call this is because, like, when you insert every value from negative infinity up to positive infinity, you will still get the output value. So it means that all values of x values are not inhibited to be put so that you get your output value. So when you input the values from negative infinity up to positive infinity, it means that all values exist. So it means that all values on your graph exist. So when your all values on a graph exist, it means that your x value, your domain, you say x is an element of real numbers because all values exist on your graph. So it means that x is an element of real numbers. So again, for y, still because of for every x value that you input on your graph, you still get your y value. It means that all your y values exist. So it means that for every x value, a y value exists. For every domain, a range exists. So it means that y is an element of real numbers. Why am I saying y is an element of real numbers? Because every value from this line exists on your graph. So you cannot inhibit it. So it means that every value exists on your graph. I guess you understand this, guys. So if you don't understand, type on the comments so that we can explain further on what we're talking about when we say range. And we refer you to specific sources where you can study about the domain in range.